Good morning. My name is Lara Abrash. I'm the chair of Deloitte in the U.S., and I'm really excited to be here with all of you today to talk about Beyond Earth, the next space race. Likely, like many of you in this audience, I grew up in a time that we got to watch rockets take off. We got to see them land on various planets. We got to see space exploration all through the eyes of what a government or a country were doing when they would put a flag down and start to explore. What we're going to talk about today is some fundamental changes about how we're thinking about space today and the experiences this incredible panel is going to bring to you. We're seeing an incredible transition from government, countries, flags with that same excitement to real commercial opportunity. And it's not just a space industry opportunity. We're seeing every industry take advantage of what space can offer them. We see it in all of our clients here at Deloitte, solving so many different issues to make sure they're taking advantage of what space can offer. They're looking at strategies, opportunities, what are the risks? They're thinking through things like, what do I need to do to tech enable? How do I address cyber? How could I collect immense amounts of data and leverage AI all in the real time? Things like taxes, all of that is being considered by organizations around the world. We at Deloitte even launched our own satellite, Deloitte One, which is super, super exciting. So today we're going to talk about what we're all seeing. I've got a laugh over there. That we have a satellite? Was that the laugh? Or the name of it? It wasn't original. You could do it. We could have done a Deloitte too, but I don't know. Then people would have thought there was one. We got to laugh over the fact that we have a satellite. I love that. So anyway, let's get started with our panelists. I'm going to ask each of them to share a bit about their background, and we'll start with you, John.
Yeah, I'm John Gedmark. I'm the co-founder and CEO of a company called Astranis. Astranis builds a new class of satellite. These are very small and very powerful satellites for high orbits, so geostationary orbit, some other specialized orbits. And we do that to provide an array of services for different customers around the world. With geostationary orbit, you can actually park a satellite overhead over a country and have that satellite be this dedicated asset for just a single country or customer. And that's allowed us to put up satellites that are providing this very unique kind of sovereign service for different countries around the world. We also work with NASA and Space Force for similar missions.
Great. Samantha?
Yes, good morning. My name is Samantha Cristoforetti. I'm an astronaut with the European Space Agency, originally from Italy, but since I've become an astronaut, I live in Germany with my family. I've had the amazing opportunity of spending twice half a year in space on the International Space Station. The last time was a few years back, was in 2022. I'm not sure whether I'll have a chance to fly to space again, but who knows? It's not impossible. In the meantime, for the last couple of years, I've been working on spacecraft development, actually in part with the lady over there. I've been responsible for a project which is called, stay with me, LEO Cargo Return Service. It's a bit of a mouthful, but LEO is low Earth orbit, so very different from geostationary. LEO is about 400 kilometers. That's where we have the International Space Station, where we'll have future space stations, and we want to develop in Europe vehicles that are able to fly cargo there and back. And maybe, hopefully, one day, also humans.
Great. Dylan?
Wonderful. Hi, I'm Dylan Taylor, Chairman and CEO of Voyager Technologies. We're aerospace, national security, and traditional space company listed on the New York Stock Exchange, based in the U.S. The signature infrastructure project we're working on is a space station called Starlab that's in partnership with Airbus, Mitsubishi, and several other companies around the world. And we hope that will be a replacement to the International Space Station in orbit in 2029. I also had the privilege of seeing the Earth from space. I did a suborbital flight in December of 2021. Changed my life. So I'm here to tell you the overview effect is real. And when you're up there, you realize there is no other place or other people. There's only here, and there's us. That's what we are. The other thing, I founded a nonprofit called Space for Humanity that's worth mentioning. We send people to space for free in exchange for them doing something positive for the Earth. So we've sent the first Mexican-born female to space, the first Arab-born female to space. We sent Ed Dwight to space. He's notable because he was the first astronaut selectee by President John F. Kennedy. Did not get a chance to go to space for unfair reasons, in my view, and at age 92 was able to see the Earth from space on a suborbital flight, and we participated in helping him do that. So very passionate about space. I believe space is a tool for transformation. I think it's a way for us to reimagine what's possible as a species, and I think it's the best of us, represented by people like Samantha, the best technology, the best people, and I think the best values being projected out there. So I look forward to the conversation.
Great. Hélène?
Hello, my name is Hélène Huby. So I'm the founder and CEO of the Exploration Company, which is a space transportation company. Our mission is to build space vehicles for humanity. This means that every space vehicle we build it across nations to foster collaboration and peace. The first vehicle we are working on is a space capsule. I have the pleasure and the honor to work together with Samantha. We start with a cargo capsule so that we can bring things like food, things like water, things like new solar panel to a space station, which is like a house. We need to take care of the house, so we need food and beverage for the astronauts, we need the experiments for the astronauts, and we'd also repair pieces for the station, like in a house. And we've sent already 2 capsule prototypes to space. None of the flights were fully successful, but we are learning super fast and implementing the learnings on the final recurring vehicle that shall fly as per our schedule to the International Space Station in 28. And of course, our ambition is, more than that. We want to build a human-rated capsule. So let's see what we can do together between Europe and the United States. And of course, we want to build a rocket. Some of you, might have seen in the press yesterday that actually we're in the process of buying a small rocket company so that we can have a full pack capsule, rocket, and again, the rocket will be built across country to foster collaboration and peace. And this is something very close to my heart. In parallel to this job of CEO and founder of the Exploration Company, I actually founded, before that company, I founded a foundation called Karman Project, where every year we invite 15 people from all nationalities, top space leaders, and they start dreaming together about what they can do together. They start building trust, because people who change the world is actually a small group of people, and they get to know each other, they dream together, they trust each other, and then they start a project. So we hope to plant the seeds of future collaboration. On the private side, with the Exploration Company, which is one of the fastest growing companies in Europe, we've been able to raise the biggest seed, biggest Series A, biggest Series B, so like biggest fundraise of Europe. We are working together with the European Space Agency as an anchor client. This means that the European Space Agency is buying our missions, and because they buy our missions, then we can raise private money to finance the company. So this is for the private side, and the let's say non-profit side. This is this foundation, but you see with the same objective, because space is our future, and I really, really want that we build this future together in collaboration.
Renato?
Yes, good morning. My name is Renato Krpoun, and I'm heading the Swiss Space Office, which is part of the Swiss State Secretariat for Education, Research and Innovation. I'm currently also chairing the Council of the European Space Agency at delegate level, and I want to give you some insight what the Swiss Space Office actually does. We're responsible in Switzerland for space policy and space law. So Switzerland is currently drafting a new space law, which hopefully will be in Parliament by the end of this year. We're also responsible, and this is a big part also of our work, the Swiss portfolio towards the European Space Agency. So basically what programs Switzerland wants to participate. As you might be aware, the European Space Agency has a mandatory and an optional program. So we work a lot on the optional program, which subscriptions we want to do, how do we want to participate in these different programs, how do we enable the industry and create a good ecosystem for industry in Switzerland.
Great, thank you. Thank you all. So we're going to spend a little bit of time with some set questions, and then we're going to have an opportunity to open it up for questions later for all of you. So be thinking about your questions. This one is going to be for all of you, and I'm going to ask that we try to keep our answers a little condensed so that we can get through as much. I'll start with you, Renato, and come back. How do you define this next space race, and how do you think it's different than the last one?
I think the last space race was about the systems, communism towards capitalism. Who is better? Who is more performant? And now we're in a different logic. We want to go to places like the moon, the low Earth orbit, and we want to stay on a much longer basis.
Yeah, I have so to add perhaps things you. It's true that at the beginning we wanted to discover. This is still true for Mars. We've not been, we've not yet sent humans to Mars, but the big revolution is for Moon and low Earth orbit. So around the Earth is really to have a sustainable presence, which was already true for low Earth orbit with the International Space Station. And also, I think the very important difference is that now we have this mix of private financing and public financing. So it means that space becomes a business that can be commercialized. I'm sure you're going to tell more about that. And this is happening now in low Earth orbit, not yet at the moon, but in low Earth orbit.
Great.
Yeah, well, I think it's defined by commercial partnerships, public-private partnerships, but probably more fundamentally is the technology has matured and has converged. The way I like to think about space is really not as an industry, but really as an eighth continent. Think of it as a domain. I think you probably all have your phones with you. Your phones really don't work without the GPS constellation, right? Your telecommunications don't work without satellite-based data. All our climate data, how we know and understand the Earth, is coming from space-based assets. In the future, probably all internet access will ultimately be coming from space-based assets. There's talk about moving data centers from the Earth to space. There's this beautiful kind of vision for space that Jerry O'Neill, a Princeton professor, had, which is we can get all our heavy industry off the Earth, put that in space, and the Earth becomes essentially a national park, if you will, right? A utopia that we can preserve and cherish. I kind of like that vision. But I think this convergence of different industries, whether it's telecommunication, data sciences, biopharma, which I know we'll get to, because there's a big revolution in microgravity research as well. I think all of those things converging, I think, really defines this race. So it's less political, and it's more, we go to space to benefit Earth. It's more a matter of convergence of industries and technologies, which I think is super exciting. And I think, by the way, that's why a lot of capital is flowing into it, because they see the business case as well.
Samantha?
Yeah, I mean, I think that on the one side, we can frame the space race as normal commercial business competition and reflects the fact that, this vision of especially low Earth orbit becoming a thriving economy is starting to take shape and materialize. So on the one hand, it's like, okay, this bit of space very close to us, low Earth orbit, it's becoming a place where people compete commercially like in any other domain. And the frontier goes a little bit further out towards the moon, further out in the solar system. I think that when a lot of you hear about the space race, maybe in the media and the news, what you probably hear is more about this competition, especially between the US and China, about who gets first to the moon, right? And that, I think, is still very much political and geopolitical. What is important for me to say as a message is like, it can be an opportunity. I mean, competition, also this type of competition has driven fast-paced progress. I think it builds on a strong backbone of very strong, solid collaboration that we have experienced, especially on the space station in the last 30 years. So it's okay. Let's not worry about it too much. I mean, these are cycles of extreme competition and then cooperation that consolidates those gains. So I'm trying to see it as an opportunity and not worry about it too much.
John?
Oh, I think this is very interesting because it seems like we have different definitions of
yes.
what is the space race? Who's racing? Who against who? I think it's very clear. The West absolutely is in a race with China to get back to the moon right now. China's been very consistent in their objectives. They've said, here's the exact things we want to do. Here's the technologies we want to demonstrate. We want to put people on the moon. Then we want to put a permanent base on the moon. And they have begun, over the course of years, they've been very consistently executing along that timeline. The West, for all our, all the great things that we have, and I think, the U.S. and Europe are partners in this, we have been less consistent. We've been sort of all over the place. So, I think it's a very real open question today as to what's going to happen. We honestly, I don't think we can predict. I think there's plenty of people out there that would say China is absolutely going to win, given what they've demonstrated to date. I think the U.S. and Europe has a key advantage, though, actually maybe two. And that is, the first one is the commercial space industry that we've mentioned, and that is the big difference from the last space race, right? In the last space race, it was 100% government run, 100% government driven, and this is just a completely different situation. I think you can, arguably, you're seeing for the first time more money, more spending happening in space by the private sector than by the government. And then the second key advantage I think we have is our new head of NASA, Jared Isaacman, in the United States, who is just absolutely incredible. Best, I think it's the best candidate we've ever had for that position, and I think we're gonna see things move out very quickly in a way that I think will put the United States in a very good position in this race.
Thanks for pointing it out. As I was listening to everybody, you are not aligned. That's okay, which is actually, that's going to make it more interesting. But let's stick on the commercial aspect for a moment. Maybe Dylan, I'll come to you. You did talk about it, and you talked about the increasing role in the commercial space. What do you look at from a demand from private to determine where investment's coming from and where it's going from a commercial perspective? What are the signals you're seeing?
Yeah, well, a lot of it has to do with data processing. So again, because we built the capacity to get hardware to orbit, and here we have to credit SpaceX, we have a reliable, reusable, and probably more importantly, high cadence launch. So humanity is launching about every 48 hours to space right now, which is really unheard of. So we have now the elevator, if you will, that can get hardware to orbit. And so what has happened is there's been a flourishing of satellites. Even Deloitte has a satellite.
Even Deloitte. And Deloitte.
Even Deloitte. And there's a Deloitte 1, and I'm sure there'll be a Deloitte 2.
Yes, there you go.
But I think, if I have my numbers right, in 2025, there were more satellites launched last year than the entire history of humanity through the end of 2024. So we are going vertical. Now, a lot of those satellites are Starlink, building out the internet constellation, but there are many other business plans that now close. So a lot of this has to do with data collection and data processing and perfect information about the Earth to make the Earth economy more efficient, more secure. There's a lot of defense applications associated with this data. The next revolution on the data piece is doing the compute and data processing in space, right? So an entire technology stack is being driven around not taking the data, transmitting it to Earth, putting it in a cloud, putting AI and machine learning on it, getting an answer and sending it to the customer. Why not just do all of that in space and just literally transmit the answer? So that's the next revolution happening. And if you look at capital flows, typically data is something they understand very well. It's a very capitally efficient market, typically, and that's where you're seeing the massive capital flows. So SpaceX, for example, is going to, rumored to go public later this year. As important as their heavy lift rocket capability is, the main thing investors are interested in is Starlink, because it generates huge amounts of revenue, huge amounts of cash flow. So think of data as being the real driver, enabled by the hardware, enabled by launch. That's really what's happening.
Well, I'm glad you mentioned that. I was rattling off the things that we're seeing in clients. That drives a big focus on cyber and protection, because like here on Earth, when you have that much data flowing and you're doing compute, you also have to make sure that it's safe and secure. So,
and just on that point quickly, that's another reason why you want to do the compute in space, because if you're doing a data stream, it can be jammed, it can be interfered with, it can be manipulated. So that's another reason to do it in space.
By the way, that's what our Deloitte one of the things we're doing is actually testing a cyber shield in space. So anyway, enough about Deloitte one. So we're seeing much more momentum here in Europe from a commercial perspective as well. And so maybe this is a question for Hélène, Samantha, and Renato. What shifts do you think need to occur to help expand this even more and to create more globalization? You know, whether it's regulatory, capital market, industrial, like what other shifts do you think are going to need to happen to enable this type of growth? I'll start with you, Renato.
I think we have to understand, first of all, what commercialization means, or at least our understanding at the moment is commercialization is you're giving responsibility from the agencies towards the company. So they have the responsibility, they're taking more risk, they own the assets at the end, but they also have the accountability. And this is something the agencies are struggling with. I think we have seen NASA has a very good model, which they put in place, and now ESA is trying to replicate this model. We heard about the LEO cargo service, which is being put in place. I never know the abbreviation, it's so complicated. But the idea is really, how can the agency, instead of designing, being the master of the architecture, transfer the design towards the companies? And I think this is really the challenge. In Europe, we have an additional challenge because within the European Space Agency, we have the geo-return principle. And if you buy services in the future, is who is going to pay for these services and how do we have a return into the different member states. So this is something we're discussing. We're trying to find new models, but this is also an important part because if you want to invest as a country, and European Space Agency has 23 countries, all of them want to have some form of return, either on the utilization side or on the hardware side.
Great. Hélène?
Yeah, just before I answer your question, I'd like to take just like a few seconds so that everybody understands this commercialization and why it occurs, because I think that's really important. Before, it was like crazy expensive to send stuff to space. So I'm caricaturing, but then only government basically could afford it, and they would send satellites to space to have imageries of what is happening in the countries where, you know, they want to have information about for defense purposes, or they would send satellites to make sure they can communicate in a secure manner with, for example, aircrafts and fighter aircrafts and satellites, and they would send satellites also like the GPS constellation to make sure they can position, they can understand where they are thanks to this satellite. And what has happened is that the cost of sending things to space has significantly been brought down, as you mentioned, thanks to SpaceX. Instead that, you know, before it was like 25,000 euro to send something to space, 1 kilogram. Now it's about 2,500 to send 1 kilogram to space. And with the Starship, the next big rocket of SpaceX, it will be about 250 euro or dollar to send something to space. Okay, so it's much cheaper. On the other hand, if we look at the basic needs we have on Earth, we need to protect the Earth. So we have a need for data to master or fight against or do better with climate change. We have a need to optimize our activities, like agriculture, use less water, use less fertilizers. For that, we need imagery. We want to reduce leaks in pipelines. For that, we need imagery. Right? We want to optimize logistics so that container ships, they don't wait days before they can go to the harbor. For that, we need imagery. We need imagery in Africa so that the yogurt, you know, we can bring the right amount of the right quality to the market. So we need to understand how many people are in the market. So very, very concrete stuff. We need access to the internet everywhere in the world. And space is great for that, of course. And we need positioning with GPS, etc. So there is a big demand from each of you, also from machines moving everywhere, etc. And space, because now it has become affordable, can answer these demands, hence big market, hence private investors coming into space business to finance new ventures, new companies who can build new products on the Earth to answer these demands about data, to serve agriculture, to serve transportation, and also to serve communication needs. So just wanted to make it very clear. Now, so in Europe, what do we need? 3 things, I think, so that we can really embrace this commercialization, because we are lagging behind top companies in the world, like who are based in the US. Number 1, I think we need more ambition. For me, a European company shall not only aim at serving the European market, because European market is much smaller than American market. So when we start a company, we must aim at serving the world as much as possible. Europe has a collaborative spirit, and we can scale it to the world, and there are also other markets, MENA, Africa, Oceania, where we have a competitive advantage vis-à-vis the US. And for certain products, like, okay, we are building a capsule, there is a big need in the United States for additional space capsules. And the United States are very happy, actually, that we are bringing also to the American market an additional facility, because the more capsule we have, the safer it is to send astronauts, to send cargo to space stations. So we need to think bigger. And this is true for the institutions and it's true for the entrepreneurs. Number two, and this is what, and I'm super proud and very grateful to the European Space Agency, the public money. We don't need that much subsidies, but we need the public institutions like European Space Agency or the governments to act as anchor client. I take one example. The European Space Agency has decided to buy missions, that is to say, hey, I am the client and I am going to buy a mission, like, you go to the post office and you buy, from DHL or Chronopost, a mission to send the gift you want to send to your grandma, and basically the DHL is doing that logistics stuff for you. So the European Space Agency is acting as an anchor client saying, hey, I want to send cargo to the International Space Station, and I'm going to choose companies to do that for me. And they are organizing competition, and they choose companies that, and we're going now to bring this cargo to the space station like DHL. We got, for the time being, 25 million from the European Space Agency. But what we've done with this 25 million, of course, we've been working on our vehicle, but we've told investors, look, we have now a client, and if we succeed with our first flight, they're going to buy more and more. And by the way, they just said that if we succeed, they can buy, the mission number 2 and number 3. And because we only with this 25 million, we've been able to raise more than 300 million. So you see the leverage effect of public money when the institution acts as anchor client. And this is what NASA has been doing in the past 15, 20 years, and this is where now we are going with the European Space Agency, and this is super important because you as taxpayer money, we need to make sure that your money is invested in the most efficient way. And last but not least, where we really also need to improve actually is speed and cost. We have a cost advantage because engineers in Europe are much cheaper, much more affordable than engineers in the United States, but we're too slow. And we accept to pay for programs which are still too expensive. So that's also coming to the first point, a mindset question, where we shall be adamant with ourselves regarding cost and speed, so that we prefer things being done faster, with a bit more risk, and cheaper, with a bit more risk. But the faster we go, the faster we learn, the faster we adapt, and the faster step by step we get a product which is one of the best in the world.
Great, thank you. Samantha?
Yeah, I mean, a lot has been said, but yeah, maybe what I can add is that I think we're trying, and Renato, correct me if I'm wrong, but I think that from the space agency side, we're trying to square a little bit the circle between needs that are very real and concrete for our industry and for our member states, and sometimes they come into conflict, because on the one hand, I'm absolutely aligned with what Hélène said. I think that speed and cost should be our polar stars if we want to come onto the world stage with our European industry with products and services that are competitive. On the other hand, there is a lot of talk about sovereign capabilities, about bridging this gap that we have, in particular to the United States, because choices were made historically to maybe focus on niche capabilities, and we've neglected a little bit those strategic capabilities like transportation. And so those capabilities right now are seen as absolutely strategic. So on the one hand, we want to focus on cost and speed and take risks, maybe also with new company like Hélène's company. On the other hand, we don't want to take too much risk because we want to make sure that at the end those capabilities do exist because we consider those strategics. So it's a fine balance that we have to work together with our member states, and we're doing our best, and I'm confident we'll be able to do it in the best possible ways. It's very encouraging, I think, that our industry is diversifying. I mean, we see a lot of new companies popping up, not only the exploration company, a lot of, actual access to space, like rockets was mentioned. There's a lot of new rocket companies popping up in Europe. And there's actually a lot of private investment. I mean, I think that the global, let's say, capital is rediscovering Europe also in the space sectors. If we look at the trends of the last few years, the percentage of private capital that Europe has captured globally has increased dramatically. So I think that there is a recognition also from smart capital and smart money that there are a lot of untapped opportunities here in Europe.
Great. Well, thank you, the three of you, for a very comprehensive view of Europe. John, I'm going to come to you. Astranis has been significantly expanding internet access through satellite. How do you think that's going to reshape the global digital access, and what do we need to do to scale this?
Yeah, I did want to just touch on the commercial space piece first, actually. So I think it's very interesting that, to me, we've seen this play out quite successfully in the United States. So there's a lot that can be learned from that. The key, in my mind, is encouraging an industry that is dual use. Dual use means you have the developing capabilities that are used by the government in place of the government having that as just a purely government-run program. But they also have commercial customers. They have customers in the private sector, and ideally, you are developing technologies and capabilities that are being used, the exact same thing or very close to it, in both for government customers and then also commercial customers. It's actually a hard thing to do. It's harder than people think, but it is to me very clearly it should be the objective. That is how you get the private sector capital really coming in, is they see a larger set of customers than just the government for a particular company or product. That is also how the government gets this benefit of really reduced costs, because they're really sharing across as just one customer. And then they in many cases can completely change the business model, so they can move over to being a buyer of services instead of a buyer of a physical assets that they sort of take possession of, and then they sort of do with it what they want. So we've seen I'm very encouraged by some of the things we've seen in Europe. There's been some fantastic space startup success stories. ISI is one that comes to mind. So very encouraged by how things have begun to play out here, and it's very nice to hear some of the things from my fellow panelists that I think we're on a very good path there. When it comes to connectivity, look, we still have a huge problem worldwide. We do still have, with all the things that with all the wonderful things that have been launched and are operating today to provide connectivity, we still have 4 billion people that are not that don't have reliable broadband connectivity access. It's quite a shocking number, actually, when you think about it. And people think of Starlink as this fantastic success, which it is, in what it's trying to achieve in terms of primarily the goal is large amounts of revenue to then support missions to Mars, right? That was always the stated goal. But they actually only have a few million customers and users around the world. If you think about it, we've barely even, that's a rounding error on the 4 billion people that we need to get connected. So the amount of scaling that is required, and the amount of connectivity across many different platforms, that includes ours in geostationary orbit, where we're scaling up, building many dozens and then hundreds of these satellites that's other connectivity solutions. I mean, there's a whole array that are being developed. But I mean, we're really just getting started on solving this problem. It's just such a. I truly think it's one of the most. It's one of the most epic challenges that we've ever had, which is to try and solve this problem worldwide of giving people the connectivity they need.
Great. Well, thank you. Maybe I'll pivot us a little bit. Let's go a little bit deeper into space now. And I'm going to start with you, Dylan. You've been quoted as saying space is essentially a general purpose technology. And we talked a little bit already about some of the commercial opportunities that exist. What sectors outside of aerospace do you think will first feel the impact from space, and why?
Right. Well, we talked a little bit about data, but maybe I'll focus on another one, which I think is relevant, hopefully, to everyone in this room, and that would be biopharma. So for those of you who don't know, microgravity is sort of a magic laboratory. And to be clear, when we say microgravity, we're talking about roughly 400 kilometers above the Earth, the orbit of the International Space Station, in free fall. And when you're in free fall, you're not experiencing the effects of gravity. What's interesting about that is you don't have the convection and you don't have the weight of gravity. So you can do some really, really unique things that you can't do here on Earth. For example, you can grow perfect crystals. When I say perfect, I mean perfect, no defects. You can extrude perfect optical fiber. You can make essentially perfect silicon wafer chips. You can do unique protein folding and molecular biology that you can't do here on Earth. You can actually print, and I know this sounds crazy, but print organelles, print a meniscus, ultimately print an organ in microgravity. So part of the reason commercial space stations are a thing is we're really at capacity on the International Space Station, both in terms of space for lab experiments, but also astronaut time and things like that. So think of lots of laboratories, special purpose for a lot of these biopharma applications that would not only do the science to make sure we perfect the power of microgravity, but then ultimately scale that up to do in-space manufacturing on a lot of these promised technologies. And imagine a future, I don't know what the median age in the room is, but I'll assume it's 40 years old. Imagine a future in 25 years where you need a new organ and your stem cells could be transmitted to an orbital space station, and you could get a perfect organ printed that's going to match your biology, that won't be rejected because it's going to match your DNA, and that can be printed in microgravity. And of course, once it's completed, then you can put it in gravity because it won't collapse, and then it could be inserted in your body. So I know this sounds crazy, it sounds like science fiction, but we have the technology to do this. It's a matter of perfecting it and then ultimately scaling it up. So if you look at biopharma, whether it's Merck or Pfizer, and of course Switzerland's one of the key biopharma capitals of the world, there are billions and billions and billions of dollars of capital focused on drug development. Keytruda, which is a breakthrough lung cancer drug, was primarily developed on the International Space Station. So I see huge promise in biopharma. And it's not only, again, I want to come back to the theme. We go to space to benefit life here on Earth. Yes, there's a business case. Yes, people will make money. But fundamentally, it'll make humans' quality of life better and minimize suffering. And that's really the key thing. I go back to John's point on internet access. Why? Is it to surf TikTok? No, it's to unlock this human potential for people who don't have broadband access. And ultimately, that benefits the world. And I really want to emphasize that. We go to space to benefit Earth.
Thank you so much for sharing, even though for some of us it may seem a little bit out there. But it is a really specific example for people to really start to understand, like, these are really different and unique opportunities, and we need all of you to help us get there. So that's amazing. Maybe, John, I'll come to you. What do you see as sort of the next breakthrough that we can do we got a little bit of the biopharma, but let's use a 5-year time frame. What's the next transformation that you see?
John, you might have dropped your mic.
No. Certainly the single biggest change agent, the single biggest thing that has had an impact for just across the space industry is the reduction in launch prices that we've seen over time, and that has come about primarily due to reusability. You know, you could just go back not that long ago, and people thought this was like a far off, you know, completely unthinkable thing. And then, of course, first SpaceX proved it out with the Falcon 9 rocket, and they now do that almost every single day. And now other companies are starting to do it for the first time. So, you know, now we're looking at them scaling up with Starship, and Starship as a, you know, just the reusability that they are achieving there is it's actually a new kind of reusability. And there's other companies that are doing this as well. A friend of mine runs a company called Stoke Space, which is also doing full reusability. Full reusability means they are reusing both stages of the rocket. And that is actually another unlock for even, instead of just reusing the first stage, throwing away the upper stage, now this is an even further unlock for launch prices coming down. And then, of course, there's the sheer scale of the activity that's happening, whether it be the scaling up of size of Starship or, you know, the increased launch cadence of other rockets around the world is just having already a dramatic impact.
Oh, amazing. Okay, maybe we'll do one for all of you. We've talked a lot already about some of the benefits that are out there, and we touched a little bit on this, but Renato, I'll start with you. How do you think we need to evolve these private and public partnerships to make sure we achieve these benefits globally? We've talked a bit about that, but maybe you could expand, and then we'll go through everybody.
I mean, from our side, this is a very important question because, I mean, let's say on a national scale, we're trying to position the ecosystem, but also support through our ESA participation, the European scale. So for us, the question is really, we see this future coming. You mentioned the organs in orbit, the pharma opportunities we will have. And for us, there is still a gap in between. And I think there is a lot of research which needs to be done. There is also the right facilities which need to be available. And this gap we will need to bridge over the next years. And also the question of availability. We need to be able to launch as quickly as possible to get to the speed necessary to evolve the technologies and to evolve also the products. We have to move from an economy at the moment which is very strongly supported by government to an economy which then, a space economy which is then supported by the private sector, where the private sector will be the final customer. And I think this is the step we're trying to do.
Great. Anything to add?
No, because I've spoken too much before. So.
Okay. Dylan, anything you want to add here?
No, I think it's been covered.
Okay. Great. John, anything? Okay. Well, then I'm going to pivot to Samantha. We have an astronaut. I was going to say that not a lot of people have actually spent a year on Earth that are actually still alive. Until I found out you actually went up, I was going to say on the stage at all, but a year out there. I mean, how do you see the future of human spaceflight? And maybe just a little bit of your own story here would be interesting to hear.
Yeah, absolutely. So I'm, a little bit of the classic astronaut story. So I grew up in a tiny little village in the mountains in Italy, so maybe not so obvious that you end up becoming an astronaut. But I do think that it set me on the right path because, you know, you grew up in a place very much like Davos, maybe not so glamorous, but very similar in the landscape and size and remoteness. But it set me on the right path because I had a very direct connection to the night sky, very little light pollution, and it was a very strong presence. And then, you know, that I think triggered my fascination. But then, of course, I had all the opportunities that, school and books and TV shows and all of that offers you, even if you grew up in a remote location, to connect to that amazing human adventure, which is spaceflight. And, you know, I grew up in the 80s and space shuttle was flying and there were men and women going back and forth all the time, and somehow it was crazy enough to assume that, you know, I'll do that as well one day, and somehow it didn't happen. The first time I went to space station was in 2014-15 on a Russian Soyuz vehicle. So it seems a completely different age. It was all of these changes we've talked about were obviously in the making, but I certainly wasn't particularly aware of them. Right, I was focused on my mission training. It was a very long training flow, and I was learning Soyuz, which is a vehicle, very much a legacy vehicle from the 70s, 80s, modernized over time, but very much that legacy vehicle, and that was spaceflight for me. And then I served a year on the International Space Station. And again, it was before we started seeing all this trend towards commercialization. And then boom! I mean, I think all those changes that had been in the making kind of like all came together and started materializing. So when I flew in 2022, the landscape, the context had changed significantly, I would say. I mean, the space station is still the space station, but boy, there was so much more going on. And you could tell just by the, you know, on my first flight, if I wanted to find a corner on the space station to, I don't know, set up my own private little experiment or something, right? That wouldn't bother anyone, and it was fine. I mean, you could find little corners like that on the floor, on the wall, wherever, it doesn't matter. But in 2022, it was hard because every little, you know, square centimeter or square foot, I mean, not square, cubic centimeter or cubic foot was taken. The sheer amount of activities, research facilities had incredibly increased. So when you say we're out of capacity, I can definitely testify to that. The other thing that had changed is that we had started to see a lot more of those commercial, we call them payloads, because this in the end are the ones that, you know, in theory pay the bills, right? Because they are the actual useful stuff that you get out of space station as outcomes of experiments. So with this fancy word payloads, we started to see a lot more of those commercial payloads. How did we even know as astronauts that they were commercial? Well, because maybe there were more restrictions on taking pictures, on sharing data, which is normal, right? I mean, if you have a commercial customer who flies their experiments, they certainly want to own the outcome and the data because they're paying for that, and they want a return on their investment with the proprietary technology at the end or a proprietary product. So we certainly saw a lot of that going on, which I think is showing this trend. And then, of course, I flew to station not on a Soyuz rocket and vehicle, but on a Falcon 9 and a Dragon spacecraft, which is much more, it's a spacecraft of the 21st century, so much more comfortable for sure as an experience, and also much more automated. And then the other thing that I will mention is that, again, from personal anecdote, when I flew with my crew from Houston to Cape Canaveral to Florida to launch, we were supposed to be launching after 4 days. That's the usual timeline. 4 days before launch, you fly from Houston to Florida, and you get those final activities, and then you launch. And it can happen, of course, that you get delayed for a number of reasons. Usually it's weather. Usually it's launch weather. You don't have good weather to launch, either on the launch site or somewhere in the ascent corridor. The weather is so bad that if you had to abort the launch and the rescue folks would have a hard time getting to you. So that's usually what drives the weather situation, right? But what delayed us by a whole week was actually landing weather, splashdown weather. Not for us, not for a NASA or government crew, but for Axiom 1. They were the very first purely private mission to the International Space Station. So the mission was commanded by a former NASA astronaut, but the other 3 gentlemen on board were paying customers who had bought themselves a ticket to go to the space station. And they didn't have good weather for splashing down. And they had our parking spot up there, our docking port, so we couldn't launch if they didn't come back. And so we were stuck there for over a week waiting for them to come back. But that's also a significant change, right? When I became an astronaut in 2009, I would have never imagined something like that, right? So just to give you an idea of how things are evolving fast.
So I'm about to open up the questions. I could listen to these stories all day, but I just want to ask you, as you were coming back, what was like the one thing you were like, oh God, thank God I'm coming back to Earth because I get to
take a shower?
Take a shower. Fair enough. All right, I see already a question over here. Let's just let you get a mic, if that's okay. And if you could maybe just introduce yourself, we'd appreciate that, and where you're from.
Yeah, I'm Sylvia Kohlmann from Rostock, Germany, and thank you so much for the inspiring panel. I used to work for the GNSS Galileo for the German Aerospace Center and for Airbus as well, under Professor Werner, who later was then the director of the ESA. And my question is going to Mrs. Cristoforetti and Mr. Taylor, because I found your insights very inspiring. And maybe if you like to share, what kind of recommendation or clue would you give your younger 10-year-old? Because I like to learn a little bit more from your experience. Thank you so much.
Thank you. I think that was for you, Samantha.
Yeah, well, I happen to have an almost 10-year-old.
For your younger self.
Oh, my own younger self. Oh, my God. I'm so happy with my life overall that I wouldn't change anything, because you think you're improving something, but you never know what really, what really happens. So maybe I'll stick to my own 10-year-old and any other 10-year-olds. I mean, I think what's really important at that age is to let them try things out and see and understand where their passions and their talents are. Because I've astronauts specifically, they come from all walks of life, but they're usually fairly happy and fairly happy people, and they're really usually pretty good at whatever they were doing before. And I don't think you can do that unless you find some kind of passion or something that you're really passionate about. So, 10 years old, I mean, I try to influence my daughter as little as possible, but give her all kinds of opportunities to just try out and see what she's going to be passionate about.
Great, thank you. I'm going to go to the back over here with the white jacket, and then I'll go over here next.
Thank you. Thank you very much for this very interesting panel. I'm Dragana Popovic-Renella from SENIS in Switzerland. We supply precision magnetometers also to the space industry. And my question is, if we are moving towards a cooperative responsible space model, what do you think will be the main constraints, systemic constraints for small, medium suppliers? So will that be like qualifications, requirements, or simply procurement pathways? And how can public agencies support SMEs in moving faster or scaling into these global missions? Thank you.
Who wants to take a shot at that?
I've got one thought on the topic. I would say standards. So part of the reason we, the royal we meaning humanity, can't move quicker on some of these supply chain issues, whether it's in the US or Europe or elsewhere, is we don't necessarily have all the right standards that we can all agree on. And I think if we had a governing body, and I would welcome the WEF's participation on this, I've brought it up to the WEF in the past, we don't really have an overall governing body that can weigh in on some of these standards. And so we have European standards, we have an American standard. But I think the more standards we have, the more alignment we can have, the faster we can go. Costs would also be reduced pretty dramatically. And I think it would help out a lot of mid to small suppliers to plug into a larger ecosystem. So that would be one suggestion I would have.
Yeah. Perhaps just to complement, because the question was also about the role of the agencies. It's to basically support the companies to actually meet with these standards, if we can come to international standards. To give you a very concrete example, where we are building right now, with the support of the European Space Agency, a capsule that's going to dock to the International Space Station. And for that, we need to meet the American safety standards, because of course we shall never collide with the station. And we know very little about human safety in Europe, because we never built a vehicle that would fly humans, like for real. We had projects, but we never built a vehicle that actually came to flight. And the collaboration we are having with NASA and with the European Space Agency is for us extremely important so that we can understand what is the intent of these standards and how we're going to meet them so that ultimately we can fly. And if we cannot meet the safety standard, there is no chance that we're going to fly. So I think this is the role of the agencies to be these translators, to support the industry understanding and building spacecraft that really meet the standards.
Great, thank you. Back there with the glasses on. Yeah, that's you.
Hello, everybody, and thank you for a very stimulating conversation this morning. My name is Jennifer Rogers. I come from Ireland, and I work between arts and business communications. My question today is for Taylor. I found your proposition of microgravities and the possibilities for stem cell regeneration and printing human organs absolutely inspiring. And my question to you today is, how do we, as storytellers, as cultural creators, have to start thinking about managing these realities that are going forward? What can we do today to empower our people to work in these cultures of the future?
Yeah, it's a brilliant question, and I do think about this a lot because I think space is going to happen whether we want it to happen or not, and I think it could be an extremely positive influence on the future of humanity, but we have to shape it. And to your point, you know, escape from Earth, kind of billionaire boys club is one narrative. The other narrative is this power to benefit life here on Earth. And I think microgravity research is something that the world can really rally around. So I would encourage you, you know, there's quite a few companies out there doing real research on the International Space Station today. We have a partnership actually with several universities, one of which is the University of Zurich. And there's a research consortium called VISTA, and it's Ohio State University, University of Zurich, and others. And the whole idea is to do the real work on research areas, whether it's biopharma or ag tech or other research areas, and take that research docket, if you will, and translate it to real missions, real payloads, real science in microgravity to benefit life here on Earth. So those stories are out there, and I would encourage you to, and if you want to follow up with me directly, I can point you in the right direction. But I think it's really, really, really important that we start talking about the promise of space. You know, a thought experiment that I'll just share with you that I like to use because we have a bit of militarization in space as well, right? So to me, the future of humanity in space really will be determined by the answer to a question. And that question is, what will happen first? The first human born in space or the first combat fatality in space, right? And I think we in this room can help shape the answer to that question. I hope it's the former and not the latter. But to do that, we have to do the science, and we have to, and I just want to brag on Samantha for a moment. You asked the 10-year-old question, which is a brilliant question. My advice, if you want to be a professional astronaut, be collaborative, be an abundance thinker, because every astronaut I've met, whether they're Russian, Korean, European, male, female, fighter pilot, which Samantha is, or scientist or artist, they are some of the most collaborative, I would say collegial people you'll ever meet. Because if you are a chest pounder and a me first person, you will not make it through the astronaut corps. And so when I talk about us projecting the best of humanity into space, I'm talking about people like Samantha in this notion that we as a species really have a duty to each other to make the world a better place. And I think that's really what space is all about.
That's amazing. Okay, who's next? Take this gentleman here.
Hi, Abdulwahab Al-Athim. I came from Saudi Arabia, mostly working in AI investment and as advisor. So my question actually to Ms. Taylor, that also touch some points that Samantha have mentioned, which is the moment that people speak about physical AI and they want to move into physical AI where robots can actually handle a complete ecosystem, the first application that came to my mind actually is space. Because it's so difficult to send a human, there is a many constraints, and Samantha knows that many of these. But then I realized that people want to go to the space. So there is a huge race of people going to space instead of building this physical AI and leveraging it to go to the space. So from a commercial point of view, to Taylor and also to the Samantha, what do you think about what's going to be in the future? Samantha touched a point is the new rocket. It's become more autonomy. But are we going to reach where there is a full autonomy in the space industry or not?
Yeah. So the notion is send humans or send robots. In some cases, you might be able to do both. Because imagine you're an avatar and you're manipulating a robot that's on the moon, for example. So that's one way to go. The holdback for doing, I would say, physical AI in space has been latency, right? Because you have the speed of light. Even at the moon, there's some time lag there. But with intelligence evolving as rapidly as it is, and you can actually have autonomy because the piece of hardware can actually make decisions on its own based upon input. I'm in the camp that says there's going to be much more autonomous physical AI doing a lot of the hard jobs on the moon. So for example, helium-3 is on the moon. Helium-3 is relevant for quantum computing. Helium-3 is relevant for fusion. You could send a bunch of humans up there to mine helium-3, or you could send a bunch of autonomous, intelligent, physical AI robots to do that kind of work as well, under human supervision as well. So don't think evil robots taking over the moon. But I think that's likely where things are going to go. And the technology, as you know, is evolving incredibly rapidly. But the part that people didn't anticipate, let's say 5 years ago, is how much intelligence you can embed on the physical AI. That's what's changed the game, I think, fundamentally.
Yeah, I fully agree. And I mean, this is really an open question, and it will be up to us collectively as humanity, as these intelligent robots evolve to understand, decide, shape what we want to hand over to them, as opposed to keep as our prerogative, and not only in space, but I suspect on Earth as well. I will share one anecdote, though, that actually two things I'd like to share. One is, when I came back from my first mission, one of the things we like to do as astronauts in space, as you might know, is free time. There's not a whole lot of things to do. You can go to the movies, you can go out for a walk. So one of the things we do a lot is like take pictures. We have this amazing view of the Earth, and we try to capture and share that. And so, in my first mission, just like on my second, I took probably thousands of pictures, and maybe hundreds of those were posted on social media for to share with the world. And I remember coming back from my first space flight and doing, what we call the post-flight tour in my home country in Italy, go out and, meet people and talk about my experience. And something I heard constantly from people were like, we miss your pictures so much. And this really struck me, because my answer was like, I mean, there's people on board now, they're taking just as good pictures as I did, and they're sharing them, so why are you missing pictures? I mean, there's so many pictures. And I was like, it's not the same. We wanted your pictures. So, because of course it was my home country, they had developed a personal relationship with me. And so for them, my pictures were special. And then somebody else's pictures might be special to somebody else. But in general, I think it's also not the same, a picture taken by an astronaut, maybe with a commentary, how that made you feel when you saw it, as opposed to all the gazillion pictures, better pictures, by the way, optically better pictures that satellites download all the time, right? You could look at the pictures of satellites, but very few people do that. While a lot of people are passionate about the pictures taken by humans. So is that going to remain relevant? I mean, it obviously was in 2016 after my first mission. I think it still is now. Is this still going to be relevant for new generations who are like native, AIs, citizen? I don't know. Maybe indeed it will become, for people in the future, 100 years from now, experiencing, I don't know, the moon and Mars through an avatar will be enough, or will be to them just as significant as it is for us to be there, as, having a human there. That I really cannot predict. To me, that is very much an open question. But I'd like to share something else which is somewhat related, but it came up in a panel yesterday, and I thought it was fascinating, which was this idea of expanding, human intelligence and human civilization, if you want, beyond the solar system. It's very, very unlikely that in the foreseeable future we're going to be able to send actual human beings, right, beyond the confines of our solar system. But maybe one way is to send a robotically embodied intelligence that represents our collective human intelligence and knowledge and culture, kind of like with the Voyager and the disk, right, but kind of like a more advanced instantiation of that. And so that might be a way of us, in some way, reaching out beyond the solar system.
Thank you for that. I actually think this exchange is a broader exchange around like what will humans do versus the physical AI in the future, and what is that special thing that people just want to get from humans. Well, we're out of time, which I can't believe. I hope as you leave here today, you think about our theme of the week here in Davos. This is about a spirit of dialogue. That's what we had today, a lot of different perspectives. But when we think about space, this is going to be what's necessary. We're going to need to do this together. We will go farther together. So I would like you all to give a big thank you to our panelists, please. And enjoy the rest of your time here. Thank you. Sorry, we've run out of time. So sorry.